everybody, Mrs. Bowen here, and we're going to take a look at Learning Target 7.4. I can factor polynomials by grouping. So we're going to see some different methods for factoring, and grouping is one of those methods. In order to factor a polynomial by grouping, there must be, and if we look at our examples today, all of our examples have 1, 2, 3, 4 terms. So there must be 4 terms. Once there are 4 terms, and we can see here also that our terms, for example, 1, we have an x cubed, an x squared, an x, and a constant term. So you'll notice that for grouping there are 4 terms and they are set up in that way. For step 1, the first thing we need to do is consider actually our last learning target 7.3. And we first have to see if there's a greatest common factor or a GCF that we can pull out. So for step 1, I'll say pull out GCF. And again, this came from our last learning target. The greatest common factor would be the largest coefficient and variable that you could pull out of each term. In step 2, we're going to split the polynomial into 2 groups. I'm going to say split. I'm going to abbreviate polynomial as poly. Split polynomial into 2 groups. And I'll say that we'll have the first half and second half. Or in other words, you could say that your first and second term are together, and then your third and fourth term are together. Once we have it split into 2 groups, we will look at each of these groups separately. And so we will factor the greatest common factor, we could say the GCF. So factor GCF out of first half. And then factor GCF out of second half. And factor our greatest common factor out of second half. So we're using this greatest common factor in multiple steps here. I left a little bit of space for us to make a note here, so I'm going to put a star. And I'm going to say that if our third term is negative, the third term is negative, then we're going to have to pull out the negative. Pull out the negative. So you'll keep that in mind when you're looking at the GCF. It'll make more sense when we take a look at an example. But when you're trying to look at your second half and you're trying to pull out your GCF or your greatest common factor, if that third term is negative, then you're going to want to pull out that negative. And then our last step, once you have already factored the first half and the second half, then our final step here, step 4, is to factor out the common polynomial factor. Factor out the common, I'm going to abbreviate polynomial as poly factor. And so you'll see that there will be something in common that we can pull out, and then we'll be finished. So 4 steps, we keep seeing GCF, the word factor. We'll see what this looks like here with some examples. So our directions tell us to factor each completely. And in example 1, I have a polynomial with 4 terms, so I'm good to go there. I have all 4 terms. And so I can look at step 1. So my step 1 tells me to pull out a GCF, and that's if I can. So in example 1, is there anything that I could pull out looking at coefficients out of 3, 9, 1, and 3? No coefficient that I could pull out of every term. And then when I look at my variables, I can't even pull an x out because here my constant term has no x. So the first step is review of what we did in our previous learning target. So step 1's already done for me. On to step 2, I need to split my polynomial into 2 groups, the first half and the second half. So what I like to do with my pencil is simply draw a line like this, and I'm splitting it into 2 groups. So my first half, I'll look at my first and second term, and then for my second half, I'll look at my third and fourth term. So I split it into 2 groups. On to step 3, which tells me I'm going to factor the greatest common factor out of the first half. So I'm going to ignore the second half of my polynomial, and I'm just going to look at the first and second terms. And I need to pull out a GCF, or a greatest common factor, like we've been practicing. So what is the greatest coefficient or number that I could pull out of 3 and 9? That would be a 3. And then I also need to consider what is the greatest variable that I could pull out of x cubed and x squared. That would be x squared. So there would be my GCF. And once I've pulled out the GCF, keep in mind, this is like backwards distribution, where I need to say 3x squared times what gives me 3x cubed. Well, we've already taken care of the 3. The only thing we need to add in here, x squared times what gives me x cubed? That would be x. X squared times x gives me x cubed. And then for the second term, the x squared is taken care of, but I need to say 3 times what gives me 9? That would be 3. So I'm done with my first half. Now I can ignore the first half, and I'm looking at my second half of the polynomial, and I need to pull out a GCF. If there's nothing that I can pull out here as far as looking at a coefficient, you can always pull out a 1. So I'll pull out a 1, and then I'm going to say 1 times what gives me x, 1 times x gives me x, 1 times what gives me 3, 1 times 3 gives me 3. So if there's no GCF that you can pull out, you can always pull out a 1. So now I'm on to my last step, which tells me in step 4, factor out the common polynomial factor. And what I mean by that is if you've successfully factored by grouping, you should notice something in common. In both instances, I have an x plus 3. So that would be my common polynomial factor. So I can pull that out, and I would be left with, if this is my polynomial and I pulled out an x plus 3, then I have some leftovers here. I have 3x squared and a positive 1. Those would be my leftovers. And so this would be my final answer. I factored out the common polynomial factor, which was x plus 3. And then here would be my other factor. So I have 2 factors. One factor is x plus 3. The other factor is 3x squared plus 1. Let's take a look at example 2. So my first step, pull out a GCF from the overall polynomial if I can. And in this case, there's no number that I could pull out of 30, 12, 25, and 10. And I also can't pull out a variable. So on to step 2, where I'm going to split my polynomial into 2 halves, first half and second half. I'm just going to look at the first half. And what is my GCF that I could pull out? So I'm looking for the greatest number that I can pull out of 30 and 12. And that would be, let's see, 6. 6 goes into 30 and 6 also goes into 12. And then the greatest variable I can pull out of a cubed and a squared would be a squared. So now I'm doing my backwards distribution. So 6 times what gives me 30? 6 times 5 gives me 30. A squared times what gives me a cubed? A squared times a gives me a cubed. And then now I need to figure out 6a squared times what gives me 12a squared? That would be a plus 2, because 6 times 2 gives me 12, and we already have our a squared taken care of. So now I can ignore the first half. I'm moving on to the second half, and I'm trying to find my GCF, and I noticed right away I could pull a 5 out here. It's plus 5. And then I need to do my backwards distribution. So 5 times what gives me 25a? That would be 5a. And 5 times what gives me 10? That would be 2. You should be starting to notice a pattern here that you better get the same thing inside of parentheses. If not, then you've made a mistake, because this is your common polynomial factor. So this is what's in common, and we can pull that out. So this would be our last step. I can pull out the 5a plus 2. That's my common polynomial factor. And then I have to write my leftovers because I've factored it out. So I'm left with 6a squared plus 5. So these would be my 2 factors. once I have factored by grouping. In example 3, is there a greatest common factor that I can pull out here? Looking at these numbers, 12, 2, 30, and 5. There is not. So I'm going to move on to my next step. Split my polynomial into 2 parts, first half and second half. I'm just going to look at the first half of my polynomial, and what is my GCF for the first half? Well, I know I can pull out a 2. I can also pull out a p squared because they both have at least a p squared. And then I need to do my backwards distribution. 2p squared times what gives me 12p to the third? Well, 2 times 6 gives me 12. And p squared times p gives me p to the third. And then I'm saying 2p squared times what gives me 2p squared? That would just be times 1. We do have to put the 1 here, though, as a placeholder, because keep in mind, when you factor out a GCF, this is like doing backwards distribution. So now I'm done with my first half. Look at my second half, and here's a spot where we have the third term, which is negative, and we made a special note of that at the top of our page when looking at our steps. And we said that if the third term is negative, we're going to have to pull out that negative. So right away, I know I'm going to write a negative no matter what. So what is the greatest coefficient I could pull out here from negative 30 and negative 5? That would be negative 5. And then put my parentheses. Negative 5 times what gives me negative 30p? That would be 6p. And negative 5 times what gives me negative 5? That'd be positive 1. Well, good, because we do have a common polynomial factor here. 6p plus 1 matches. So last step, factor out that common polynomial factor. So here's one factor, 6p plus 1. And then our second factor would be our leftovers. So 2p squared and a negative 5. So those would be my 2 factors. We'll do one more example before you try some on your own. So example 4. Is there anything I can pull out here? Do I have a GCF for my polynomial? I do not. So I'm going to split it. Notice when I'm writing, if you're choosing to write a line to split it into first half and second half, I'm keeping the negative with the third term, right? Because this isn't 9x, this is negative 9x. So right away, I know when I do get to this second half here, I will have to pull out a negative because my third term is negative. But starting with my first half, I have x squared minus 2x. And so I don't have a coefficient I could pull out. I mean, I could say that I'm pulling out a 1, but I can pull out an x. Both terms have an x. So I'll pull out an x. X times what gives me x squared? X times x gives me x squared. And x times what gives me negative 2x? That would be negative 2. Now I'm done with my first half. Moving on to my second half. We already said when that third term is negative, we will have to pull out a negative. So what is my greatest common factor here? I can pull out, let's see, 9 goes into both 9 and 18, but really I need to make sure I am pulling out a negative. So I'm pulling out a negative 9. Negative 9 times what gives me negative 9x? That would be x. And negative 9 times what gives me a positive 18? That would be negative 2. Negative 9 times negative 2 gives me positive 18. And it worked out perfectly. We can see we have a common polynomial factor. So x minus 2 is one factor. And then our leftovers, once we have factored out or pulled out an x minus 2, leftovers, we have an x and a negative 9. So there would be my 2 factors. So at this time, you have 4 U-tries, and I'd like for you to go ahead and see what you come up with. Go ahead, pause the video. Here are answers to the 4 U-tries. On the first one, my 2 factors were 2x minus 3 and 4x plus 7. On this one, my 2 factors were z minus 1 and 3z squared plus 1. Notice that if I couldn't necessarily pull out a GCF, I can always pull out just a coefficient of 1. My third one, my factors were 2b minus 3 and 4b squared minus 3. And notice the third and fourth U-tries did have a third term which was negative, so you had to pull out a negative number. And then last solution, 7n plus 1 and 5n squared minus 8. So we're going to do two last examples on the back side. And same directions, we are asked to factor each completely. And when we look at example 5, we can follow the same steps. So we first need to consider, is there a GCF that we can pull out? And in this case, there is a GCF we could pull out. So if I look at my terms, is there in this case maybe a number I could pull out of 18, 12, 48, and 32? I know for sure they're all even. And the answer is yes, I could pull out a 2 from all of those terms. So I'm first pulling out a GCF. So 2 times what gives me 18x to the third? That would be 2 times 9x to the third. 2 times what gives me 12x squared? That would be 6x squared. 2 times what gives me 48x? That would be plus 24x. And lastly, 2 times what gives me 32? That would be 16. So the only thing that's different about examples 5 and 6 is you can pull out a GCF first. So I pulled out this GCF, and this 2, I'll continue carrying it down in my problem. So now everything else looks the same. So now I pulled out the 2, and I'm just looking at what I have here in parentheses, and I can split it into first half and second half. So looking at my first half, what can I pull out? What's the GCF for 9x cubed plus 6x squared? I could pull out a 3x squared. 3x squared times what gives me 9x cubed? That would be 3x. 3 times 3 gives me 9. X squared times x gives me x cubed. Now I need to say 3x squared times what? Gives me 6x squared. That would be plus 2. 3 times 2 gives me the 6, and I already had the x squared taken care of. Now I can do grouping on my second half. What's my GCF for 24x plus 16? Let's see, 8 goes into both of them, so I can pull out an 8. 8 times what gives me 24x? That would be 3x. 8 times what gives me 16? That would be 2. And right here, this was me factoring by grouping, but what I am going to do is I'm going to pull down that 2 out front. That didn't go anywhere, so I'll just keep rewriting the 2, bringing it down. And then my last step here, look for a common polynomial factor, which I see is 3x plus 2. I'm going to bring down that 2 that was out front again, right, because we did factor out a GCF at the beginning. And so I factored out my common polynomial factor, 3x plus 2. And then I have leftover factor, 3x squared plus 8. So my final answer, I have a 2. I have 3x plus 2, and I have 3x squared plus 8. This would be me factoring this polynomial completely. Let's do one more example. In example 6, I've got some very large numbers, and I can see they're all multiples of 5 right away. 175, 35, 75, and 15. So my first step, I can actually pull out a GCF of 5 from every term. So 5 times what gives me 175 p to the third? That would be 35 p to the third. 5 times what gives me 35p squared? That would be 7p squared. 5 times what gives me 75p? That would be 15p. And 5 times what gives me 15? That would be 3. So now I can split my polynomial up into 2 parts, first half and second half. And just looking at my first half here, what's my GCF for 35p to the third plus 7p squared? Let's see, I know I can pull a 7 out of both 35 and 7. And I can also pull a p squared out because both terms have at least a p squared. So 7p squared times what gives me 35p squared? 7 times 5 gives me 35. P squared times p gives me p to the third. And 7p squared times here just 1 gives me 7p squared. Looking at my second half, I can pull out a 3 here. 3 times 5p gives me 15p, and 3 times 1 gives me 3. Don't forget, I'm putting an extra set of parentheses just as a reminder for me. Pull down that GCF that's out front. And then our last step, look for our common polynomial factor, 5p plus 1. My leftovers, I have 7p squared and a positive 3. And then don't forget, bring down that GCF that we pulled out. That is part of your final factoring. So once we have factored this polynomial completely, we have a 5p plus 1, and 7p squared plus 3. All right, last 2 you tries. Go ahead, pause the video, and see what you come up with. We can check our last 2 you tries. On the first one, I pulled out a GCF of 3 right at the beginning, and you can notice I carried that 3 down into my final answer. I split it up into first half and second half. Notice that I did have my third term, which is a negative, so I did have to pull out a negative sign here. And then the factors that I got here were 5r minus 2 and 3r squared minus 7. And then for the last one, I pulled out a GCF of 6 right away, which I carried down, and my factors were x minus 3 and x squared plus 3.